If you're in manufacturing maintenance, well, you're challenged, right? Keeping everything running smooth.
Oh, yeah, the constant pressure.
Exactly. And dealing with those uh, unexpected breakdowns that derail your day, constantly feeling like you're just reacting.
You are. It's a high-pressure world.
Yeah.
You're not just fixing things, you're supporting production, managing costs, safety, often without the full picture.
Right. So what if you could flip that? Move from reacting to being, predictive and optimized.
That's the goal.
That's really the heart of this deep dive. We're looking at how to transform that whole approach using something you definitely have,
Which is?
your data and your documents. All the stuff you already have, maintenance logs, sensor data, schedules, manuals, everything.
And we've been digging into a document that explores how a certain kind of AI, something like Strategy.ai, can plug right into that environment.
Using AI models, like the tech behind large language models, to understand all of it, the numbers and the text.
Exactly. Structured data from sensors, unstructured stuff like technician notes, even those dense manuals. It tries to make sense of it all.
Okay, so our mission today, for you listening, is to unpack 10 distinct, actionable ways this kind of system can tap into your information.
Your records, your reports.
Yes, to really boost reliability and efficiency. We want to give you a shortcut, basically, to see how your own data could mean less downtime, better costs.
And a maintenance strategy that actually helps the business, not just reacts to problems.
It feels like uncovering hidden possibilities, doesn't it?
It really does. It's about seeing patterns, connecting dots in your data that were just impossible to see before. Too complex, too much information.
Okay, that sets the stage perfectly. Let's dive into the first few ideas, which are all about getting more predictive.
Right. Shifting from reacting to anticipating, a fundamental change.
First one up, the predictive maintenance forecaster and optimizer. I mean, everyone hates an unexpected machine failure grinding things to a halt.
Absolutely.
What if you could see it coming?
Well, this capability tries to give you exactly that heads up, but it's grounded in data. It looks at your maintenance history, sensor data.
Maybe from a file like that Process Sensor Log CSV example.
Precisely like that. And your production schedules, too. It analyzes all that to predict the probability of future failures.
Okay, predicting is good.
But here's the crucial bit. It doesn't just say this might fail. It recommends the optimal time window to actually do the maintenance.
Ah, so it times it to cause the least disruption.
Exactly, minimizing the hit to production.
So ditching the old rigid schedules or just fixing things when they break, this is using the equipment's own story, its current state, to be smarter about timing.
You got it. You could ask it something pretty direct, like analyze the sensor data from Process Sensor Log CSV and the logs for Press A for the last 2 years. What's the chance of a hydraulic failure in the next month?
Okay, that's powerful.
Or you could get more strategic. Okay, considering our production schedule and the fact Mixer B's failure risk is going up next week, suggest 3 good maintenance slots in the next 2 weeks. And tell me the production impact for each.
Wow, that's specific.
Yes. And it can even dig into subtle warnings. Based on technician notes line and vibration reports, what are the top 3 early signs of bearing wear on the C-line conveyor that the system sees?
Having that kind of foresight.
Yeah.
What's the real-world impact? What do you actually see change?
Well, the big one is less unplanned downtime. That's immediate because you're catching things proactively.
Right.
And that naturally leads to lower maintenance costs overall. Planned work is just cheaper than scrambling for an emergency fix.
Makes sense.
You'll see your OEE, your overall equipment effectiveness go up. And ultimately, you make your assets last longer by maintaining them based on actual need, not just the calendar.
Okay, that's compelling. But even with the best predictions, things still break sometimes.
Unfortunately, yes.
When they do, you need answers fast. Which brings us to point 2. AI-powered root cause analysis. Yeah. RCA. How quickly can your team find the real cause, not just the symptom?
And preventing repeats really hinges on that, doesn't it?
Totally.
So this is where the AI acts like a super fast detective that's read every case file. When something fails, it can instantly chew through multiple data sources.
Like what?
Maintenance history, operational data from the exact moment of failure, technician notes from similar past events, all of it, to quickly flag the most probable root causes.
So it speeds up the whole diagnostic process significantly.
Massively. Instead of a manual investigation taking hours, maybe days, with different people having different theories.
Kind of the usual arguments.
Right. The AI just looks at the data patterns and says, okay, Based on everything we know, these are the most likely culprits.
Did you give me an example prompt for that?
Sure. Pumpix failed yesterday at 3 p.m. Analyze its history, the operational logs from yesterday, and say the ambient temperature data around them. What are the top 3 most likely root causes? Or maybe you want a bigger picture. Compare the failure patterns for Motor A and Motor B over the last year using the maintenance records for all motors report. Are there common underlying issues across both that we might be missing?
Getting that diagnosis faster?
Mm-hmm.
That has to mean less downtime per incident?
Absolutely. Faster mean time to repair your MTTR, but maybe even more important, by finding the true root cause, you slash those recurring failures.
Same thing breaking over and over.
Exactly. So your problem solving gets much more accurate and effective long term.
Okay, shifting gears a bit, point 3, spare parts inventory optimization. The eternal headache, right?
Yes.
Is your storeroom lean and efficient, or is it just packed with expensive dust collectors while you wait weeks for that critical part?
Finding that balance between cost and availability is tough.
And so how does AI help here?
It brings data to that balancing act. It analyzes how fast you're using parts, maybe from a parts usage year-to-date CSV. Cross-references that with supplier lead times from, say, supplier lead times reports. It even factors in the predicted maintenance from that forecaster we talked about.
Connecting the dots.
Right. And it can consider storage costs, too. Then it recommends optimal stock levels, trying to find that sweet spot. Enough, but not too much.
So it's not just static reorder points or gut feel anymore. It's dynamic.
Yeah.
Based on real data and future predictions.
That's the idea. For a critical part, you might ask, based on predicted Q4 maintenance from our forecaster and historical usage from parts usage year-to-date CSV, what's the optimal reorder point for bearing XYZ 123? We need a 98% service level.
And what about the dust collectors, the stuff you never use?
You can tackle that too. Using the current spare parts report, flag 10, slow-moving or maybe obsolete parts, things with 0 usage in 2 years and no predicted need coming up.
Cutting excess inventory frees up cash. Avoiding stockouts prevents downtime. That's a double win.
Huge impact, financial and operational.
Okay, moving to point 4. This feels really important. Maintenance skills gap and training recommendation. Equipment gets more complex all the time.
It does.
How do you make sure the team actually has the skills needed? And how do you spot gaps before they cause problems?
This capability looks at the data within your work order system. Types of repairs, how long they take. It can even analyze technician feedback logs for common struggles.
I'm looking for patterns.
Exactly. Patterns that suggest potential skill gaps, maybe for certain equipment or certain types of repairs, and then it can suggest specific targeted training or even just connecting people for knowledge sharing.
So it's more targeted than just sending everyone to general training. It's using the actual work data.
Right. Pinpointing the needs. You could ask something like, analyze work orders from our last 6-month report. Which equipment types have the longest average repair times or the most repeat fixes? What skills might be needed there?
Yeah, that makes sense.
Or maybe for a new system. Looking at technician notes in the maintenance logs complex repairs report, what challenges keep coming up with the new PLC? What specific training would address those issues?
Better skills mean faster fixes, higher first-time fix rates, probably happier technicians too.
Absolutely. Investing in your people pays off directly in maintenance effectiveness. It's foundational.
Yeah. Okay, last point in this predictive block, point 5. Energy consumption anomaly detector. This is interesting. Using energy use as a warning sign.
Yeah, sometimes equipment is practically shouting that something's wrong through its energy draw, even before a real failure.
How does that work?
The system analyzes energy usage data for specific machines or whole lines. It learns the normal pattern, the normal profile.
Okay.
Then it flags anything weird, sudden spikes, unusually high usage that stays high, deviations from the norm. These can indicate failing parts, friction, motor problems, or just inefficiency.
Prompting a check before the breakdown, or before the energy bill gives you a heart attack.
Exactly. You're not waiting for the failure or the bill. The AI is constantly comparing energy use to the baseline and flagging deviations.
What would you ask it?
Maybe analyze the hourly energy use for the main compressor over the last month. Are there any weird spikes or trends that deviate from normal? When did they happen?
Okay.
Or you could compare things using the oven energy batch data report. Let's compare the energy efficiency of drying oven 1 versus oven 2 for similar batches over the last quarter. Any anomalies in either one?
Catching those early saves energy costs, obviously. helps identify equipment that's struggling, and it supports sustainability efforts too.
But another valuable layer of insight using data that might just be sitting in a utility report otherwise.
Okay, great. So those 5 points really show how you can become more predictive. Failures, root cause, parts, skills, even energy use.
Using the data you have.
Exactly. Now, let's shift gears. How do we optimize the actual day-to-day operations of the maintenance team?
Right, taking those predictive insights and making the daily workflow smoother, more efficient.
So, point 6 tackles that endless list. The work order prioritization assistant. You've got, I don't know, 50 open work orders?
Yeah.
How do you decide what gets done first to minimize risk and impact?
Doing that manually is really tough. So many factors. This capability helps planners by juggling multiple things at once.
Like what?
Equipment criticality, how important is this machine, safety issues, the potential hit to production if it's not fixed, even available technician resources.
So you feed it the list and maybe an asset criticality ranking.
Yep, give it a spreadsheet of open orders, your criticality list, and it helps sequence them in the smartest way.
Moving beyond the squeaky wheel gets the grease method.
Exactly, or whoever shouts loudest. This uses data to weigh the real priorities.
See what I could ask.
Okay, here are 10 open work orders from this spreadsheet, and here's our asset criticality list. Which 3 absolutely need to be done today to minimize production risk?
It's direct.
Or for planned maintenance, we've got these PM tasks scattered around. Considering who's available and where the assets are, what's the best route to minimize travel time?
Okay, keeping critical assets running, using resources wisely, ensuring safety. Huge for efficiency.
It just brings data-driven logic to a process that's often purely reactive or subjective.
All right, point 7 hits a nerve for many technicians. Finding information. Maintenance, documentation, semantic search, and summarizer. Oh man, the time wasted digging through manuals.
It's enormous, trying keyword searches that pull up 50 irrelevant pages.
Right. Getting quick access to the right info on the job is critical for speed and accuracy.
So this capability basically turns your whole library, manuals, bulletins, procedures, into an intelligent knowledge base you can talk to.
Talk to? How?
Ask natural language questions, just like you'd ask senior tech. And the system finds the specific answer within the documents. It can also summarize long sections if you just need the gist.
That sounds amazing. So instead of searching bearing lube in a PDF, you could literally ask, what grease do I use for the main spindle bearings on machine XYZ?
Exactly that. Or find the step-by-step procedure for lubricating the RX500 main gearbox in the manuals we uploaded.
Or, if you get a complex error code,
summarize the troubleshooting steps for error code E45 on the Delta controller using the Delta controller manual PDF. Quick summary right there.
The time savings alone must be huge. Plus, better accuracy, faster onboarding for new folks.
It empowers the front line with knowledge instantly. It's a big deal.
Point 8 gets fundamental. Lubrication schedule and compliance auditor. Lubing sounds basic, but managing it across everything.
It's complex, and missing a task or using the wrong stuff can be disastrous down the line. Very costly failures.
So this tool helps manage that.
It acts like an intelligent auditor for your whole lube program. It analyzes your master lube schedule, checks it against completed tasks logged in, say, completed lube tasks, CSV.
So it spots overdue tasks.
Yes. But it also consults the manuals, like Pump Manual XYZ, for the specific requirements. And it can check your lube inventory report to make sure you're using the right type, the approved product.
Wow, so it's not just a reminder, it's checking compliance and suitability against the specs.
Precisely. You could ask, comparing the master lube schedule to completed lube tasks CSV, which assets are overdue for lubing this week?
Okay.
Or, more detailed, based on the specs in Pump Manual XYZ and our lube inventory report, is grease type A actually okay for these high-temp bearings? If not, what approved alternatives do we have in stock or listed in the manual?
Getting lubrication right consistently, that directly impacts how long equipment lasts, prevents wear, ensures compliance.
It gives you confidence that this critical basic maintenance practice is actually being done correctly and on time.
Okay. Point 9 looks outside the company. Contractor performance analyzer. You bring in contractors for specialized work.
HVAC, welding, controls.
Right. How do you really know if you're getting good value? How do you objectively measure their performance?
This capability helps you do that by analyzing data related to that outsourced work. You can look at contractor work orders, maybe from an HVAC contractor data XLS.
Okay.
Compare costs using contractor invoices XLSX, and maybe even pull in feedback from inspections or post-work survey results if you have them.
And so digest all that to give you a clearer picture.
Yeah, it helps assess metrics like cost per job, rework rates, adherence to SLAs, overall value, comparing different contractors.
So you can move beyond just anecdotes or who submitted the lowest bid and use data to see who actually performs better over time.
That's exactly the goal, you might ask. Using the HVAC contractor data XLS and invoices, compare the average cost per job and the rework rate for contractor A versus contractor B on similar repairs last year, or for more qualitative stuff. Analyze the post-work survey results, any common themes, good or bad, about the welding services from our external guys.
Having objective data like that helps you make smarter choices, optimize spending, get better quality work.
It brings transparency to vendor management, which can sometimes be a bit opaque.
All right, final point, number 10. Deals with the small stuff that can cause big delays. Predictive tooling and consumables advisor.
Yep. Running out of a specific cutting insert or needing a calibrated torque wrench right now when it's not ready, that stops jobs cold.
So how do you predict those needs better?
The system analyzes usage patterns, maybe from maintenance logs tracking in-state usage data CSV for CNCs.
Okay.
It correlates usage with job types. It can even look at text notes and technician notes or machinist feedback logs about tool wear or performance.
And based on that.
It predicts when tools might be nearing end of life or need calibration based on usage cycles, or when you'll need to reorder specific consumables based on the upcoming work schedule.
So instead of just refilling the bin when it's empty, it's using actual usage data to anticipate the need.
Exactly, getting ahead of it. You could ask, based on how often torque wrench #TW007 is used and its calibration expiry, when is its next calibration likely due? Are any similar tools nearing their limits?
Or for consumables.
Analyzing insert usage data CSV, which cutting inserts wear out fastest on our CNCs. Are there better grades or suppliers mentioned in the machinist feedback logs we should look into?
Fewer delays from missing tools, fewer defects from worn tools, better budgeting for these items. Makes total sense.
They seem like small things, but they have a big impact on shop floor efficiency and quality.
Okay, wow. We've just run through 10 really significant ways a system like this, leveraging the data you probably already have,
That's the key, using what you've got.
can potentially transform manufacturing maintenance.
Yeah.
From prediction to optimizing daily work, managing parts, skills, contractors, tools. It covers a lot of ground.
I think the core idea, the main takeaway from exploring all this is that the power to shift maintenance from, reactive firefighting to something truly smart, predictive, efficient, that power is very likely already sitting there, hidden in your existing systems, your logs, your sensor data, your documents.
And we really hope this deep dive gives you listening a clearer sense of what's possible, how you can start using what you have to begin your journey to maintenance excellence.
You don't always need a massive overhaul or brand new data streams to make real progress.
It's about unlocking the intelligence that's already there.
Exactly, making your data work for you.
Which kind of leaves us with a final thought for you to chew on.
Oh.
Given how much insight, how much potential value can apparently be found just by applying this kind of analysis to the maintenance data you already possess, what untapped potential, what hidden opportunities might be waiting right now inside your own systems?